Hi, so we're learning again about derivatives of the higher order, and this question involves knowing the quotient rule. So the question is, find the third derivative of y equals 1 over x minus 1. So a little note about the quotient rule. When you have one function over the other, so f of x over g of x, the way you apply it is you take g of x, which is the denominator, multiply it by the derivative of the numerator, and then subtract it from the numerator multiplied by the derivative of the denominator, and that's all over whatever was in the denominator, but you're going to square it. Or sorry, you're going to raise it to the power of 2. So our question is, find the third derivative of y equals 1 over x minus 1. So we're going to rewrite it for the first derivative. So g of x is just the denominator multiplied by the derivative of the numerator, and then we're going to subtract the numerator multiplied by the derivative of the denominator. And then you're going to multiply or raise the denominator to the power of 2. So that's what you get, and let's just expand on that and simplify. So you have a constant here, and whenever you're trying to find the derivative of a constant, that just turns to 0. So this whole term is going to equal 0, because 0 multiplied by anything is 0. And for the second one, you have 1 here, and then the derivative of x minus 1 here. So the derivative of x is just going to equal to 1, and then the derivative of a constant is 0. So you'd have 1 minus 0 multiplied by 1. And don't forget the negative sign here. And then the denominator stays the same. So let's rewrite this. Take the sign, negative, and then after you simplify this, it's going to be 1. And that is all over x minus 1 squared. Okay, so that was your first derivative, and now on to the second derivative. So we're going to take the numerator, and that is squared, multiply it by, sorry, that was the denominator, and then multiply it by the derivative of the numerator, minus your numerator multiplied by the derivative of your denominator. So I'm going to put this one in square brackets because of that exponent 2. And then the denominator gets raised to the power of 2 again. Okay, so I'm going to break this down a little bit. So this term again is going to equal 0. Remember, this is a constant, so that's going to be 0, so just forget about it. Let's move on to the second term. Your -1 is going to change the sign to positive. And inside the bracket of this one, you've got x minus 1, but then you also have an exponent 2. So I'm not sure if you watched the previous video, but I showed you kind of how to use substitution. It's just a little trick to make it a little bit easier to find the derivative. So we're going to take whatever's in that bracket and substitute for u. You can look at this as any letter. So let's say x squared. So what's the derivative of x squared? It's just 2x. Okay? And what did we say u was? U is this term. So we could say x to that term, if it makes it easier for you to understand. So I'm going to go 2x minus 1. So we're not done. We have to find the derivative of whatever in the brackets too. So we're going to multiply that by the derivative of x minus 1. So that's just going to be 1. So then you just get 2x minus 1. So basically what I did was I said I want to take the derivative of u squared and then multiply it by the derivative of u. So that's what I did down here. So I took, that's my derivative of u squared, and then I'm going to multiply it by the derivative of u, which is my x minus 1, and this is what I get. Okay, so again, 0 for the first one. This makes it positive. And then I don't have to put in 1 because why would I do that? And then the exponent row, when you have an exponent inside a bracket and outside a bracket, you just multiply together. So that's going to be raised to the power of 4. I could simplify a little bit. I've got the same term on the bottom as on the top, and since it's being multiplied, I can take one of them out. Okay, so I just cancel this one, and then I cancel one of these terms to make it 3. Now on to the third derivative. I hope this is starting to make a little bit of sense. I'm sure you guys know that writing out the first term is unnecessary because I'm taking the derivative of a constant, which is going to be 0. But I'm just going to write it out anyway. And then the derivative of x minus 1 to the power of 3. Okay, so again, this first term is going to be 0. So I won't bother with that. For the second term, you have your negative and your 2, so we're going to keep that. And again, we're going to use chain rule for this one. So negative 2 times 3x minus 1, 2. Remember, because 3 minus 1 for the exponent is 2. And now I'm going to multiply it by the derivative of whatever was inside that bracket, which is just going to be 1. So I won't write it down. And then x minus 1 raised to the power of 6. So let's simplify this a little bit. We get negative 2 times 3, which is 6, over x, multiplied by x minus 1 to the power of 2, and then x minus 1 to the power of 6 in the denominator. And just like in the second derivative, we can cancel out the x minus 1 squared in the top to the bottom. So again, with power rules, you're going to look at the exponent, and all you have to do is say whatever is on the denominator, take that exponent, and subtract it from whatever is in the numerator. So then you're left with 4 for your denominator, just canceling out. So you're going to have negative 6 over x minus 1 to the power of 4. I like to write it like this. And that's your answer for your third derivative. So I hope that helped. If you have any questions or comments, please let me know. And thanks for watching. Bye.